So here we go, folks. Formally learning how to factor a quadratic equation, okay? I really feel that I need to tell you this is what we're trying to do is find out where the graph of this polynomial crosses the x-axis. And it'll look something like this. It'll be something like this. I don't know exactly. But what we're trying to find are those points there. Okay, what does that do for us? Well, you know this. You know the thing. If this and $5 will buy you a great cup of coffee, right? So there's no greatest common factor, and that's you always want to do that. You always want to look. Can I divide these things by these terms by the same? It could be a variable. It could be a number. In this case, 1 is the greatest common factor. That doesn't get us anywhere. So what I'm going to do, just for the sake of argument, is I'm just going to rewrite this down here. Then I'm going to then I got to, what's A? Well, A here, let me get a different color ink. A, remember it's AX squared plus BX plus C. So in this case, A is 1, B is 9, C is 20. So write those numbers down. And the next step in this process is to take the number that's A and the number that's C and multiply them. And that's going to be 20, of course. And then why don't we write, maybe we don't have to write anything here for B. Let's just leave it alone. So now we're going to write down all those factors of 20. As you do this, you'll get faster and faster at this, and you'll be able to do this without writing these down. That might not come this year. It might come, it'll definitely come by Algebra 2. Let's see, 1 times 20, 2 times 10 is 20, 4 times 5 is 20. I think that's it, because isn't the next number going to be 10 times 2? And we've already done that. So those are the factors of 20. Now, which ones of these factors adds to give me that middle number? Well, 1 plus 20 is 21. 2 plus 10 is 12. 4 plus 5 is 9. And that's the pair we want, right? So 4 by 5 are the ones we want. So what I'm going to do is I'm going to write, I'm going to take my x squared, so x squared goes here, and then the 20 goes here. Then we're just going to write 4x and 5x. Because you remember when we did the box method of multiplying, how we added those two up? They have to have the x, and that's where we got the 9 from. So now that we've got the factors, what we're going to do is, what can we divide both these terms by? Well, I'm seeing an x. So I know I can multiply write an x here. And then I'm going to look at these terms here. And I see I can divide those both by 4. So I'm going to write 4 here. Now I'm going to do the same for the numerator, or not numerator, but for the top. I look at x squared and 4x. What can I factor out of each of those? Well, I can factor an x out. And then, you see how this is very similar to the algebra tiles? And then for this last one, what can I divide both those by? I can divide them both by 5. So how does that factor? That factors to x plus 4 times x plus 5. So that's the factorization. Now, remember how I said we're looking for where it crosses the x-axis? We know this is equal to 0. And if this isn't, so here's the trick. Here's the trick. This actually has a property. This is called the zero product property. I know that 0 times a number equals 0, and then a number times 0 will also equal to 0. So I'm going to ask myself, when does x plus 4 equal 0? Well, if you subtract 4, doesn't x equal negative 4? And how about this other one? When does x plus 5 equal 0? Well, isn't that when x equals negative 5? So this tells me those are the two x coordinates. So of course, my drawing was wrong. I figured it would be. Let's see if I can delete that. And so what I know what it's going to look like is, well, let's see. Can I grab that? I don't think so. So I know what this graph looks like. It looks something like this. 2, 3, 4, and then 5. So this graph looks something like this. It's going to be a very skinny graph, turn around and come right back up. It might not even be something like that, but I know it crosses the x-axis at -4 and -5. And how those graph, well, we'll do more of that. You'll see a lot more of that in Algebra 2. And then pre-calc. So let's do another one. So we're going to do the same thing with this problem, except remember how the other one was equal to 0? This one's not. So we're going to set it equal to 0. That's the first thing you want to do before you try to do anything else when you're solving these quadratic equations, is always set them equal to 0. So x squared plus 30x. So then I'm going to add 7 to both sides. Oops, Dan, what are you doing? And then I ask myself, can I divide these things by the same number? Boy, it'd be nice if 7 was an even number. I could divide it by 2 or 4 even. Well, no, 4 doesn't go to 30. But 2 certainly, but it doesn't. So I'm kind of stuck, sorry. So what's A? A is 8. Remember, A is the number in front of the x squared. And then B is the number in front of the x. And C is my constant term, which you probably saw in that test, right? Which you had to make. So 30 and then 7. Then the next step in the process is to multiply the A number times the C number. So that's going to be 56. Now we want to list all the factors of 56. Well, 1 and 56. Yeah, you might ask me, why am I writing 1 times 56? Sometimes that's the factors we want. It isn't going to be here. So then let's do what? 2 and 28. Oh, Dan, 28. And then is it 56 divisible by 3? Let's see, 5 plus 6 is 11. That's not divisible by 3. Is it divisible by 4? I think so. 4 and 14. And then it's not divisible by 5. It's not divisible by 6. We know it's divisible by 7 and 8. And then we're 8 and 7. So I think that's all. That's it. Of course, maybe you already saw as I was doing this, which of these two add up to the 30? Well, hoping you see in 2 times 28, right? So 2 by 28 is what we want, because that'll add to 30. So I'm going to write my 8x squared here. I'm going to write my 7 down here, because that was C. And then I'm going to do the 2x and 28x. And it doesn't matter which spot you put them in. It's going to be the same. So now we're going to try to do some factoring. Well, let's do it this way first. I see an x I can take out. Can't I also take it out of 4? Because 8 doesn't go into 28, but 4 does. So, because 4 times 7, right? So I'm going to write 4x. And then when I look here, 2x and 7, well, the only thing they have in common is 1. So now I'm going to go moving up this way. What can I divide 2x by and 8x squared by? Well, I think it's 2x. And then what can I divide 28x and 7 by? Well, I'm hoping you see it's 7. So I think it's 2x plus 7 times 4x plus 1. Now before I do anything else, I should multiply this and make sure it works. So I'm going to get 8x squared plus 2x. Then I'm going to go 7 times 4x is 28x. I'm probably just being redundant here by doing this, but I have learned over the years that you want to make sure you've got it factored correctly before you try to do too much else with it. And that does check, all right? That does check the original. Okay, so that means we've got this solved correctly. So we've got this is equal to 0. So then we ask myself, when does 2x plus 7 equal 0? Well, I'm going to subtract 7 from both sides, and then I have to divide by 2, don't I? So, what am I doing? X has to equal 7 over 2, or 3.5. And how about 4x plus 1 equals 0? This one here. Well, I'm going to subtract 1, and divide by 4, right? So x equals negative 1/4. So this tells me that this graph, if I were to graph this, it would cross the x-axis at negative 1 1/4 and at positive 3.5. Okay, that's the solution. Okay, so for this one, we've got it set equal to 0. So let's see. So we've got it set equal to 0 already. So we don't have to move anything. And so now the next thing, what's A, what's B, what's C? So I hope you remember that this is A. The 1 that's in front of the X is B. The negative 2 is C. So I'll just go ahead and write those in here. 3, then 1, then negative 2. And then to do the factoring, we're going to multiply 3 times negative 2 and get negative 6. And then I ask myself, what can I multiply to get negative 6? Well, negative 1 and positive 6. I could also do 1 and negative 6. We could do negative 2 and positive 3, or 3 and negative 2. I guess that's it, right? That's how the factors of... So which one of these add to give me positive 1? See, B is positive 1. So which pair adds to give me positive 1? I hope you see it's this one. So I'm going to write in, so let's see, let me write here, negative 2 and 3. So then I'm going to write my ax squared, so 3x squared. I'm going to write in my negative 2. Then it doesn't matter where you write in the negative 2x and the positive 3x. Now remember, we look for common factors. So on this row coming out, I see I can factor out a 3x. On this row, I see I can factor out a negative 2. On this row, I can factor out an x, or column, I can factor out an x. On this column, all I can factor out is, oh my, maybe a 1. If they were both negative, we can usually factor out a negative, but here, I got to undo what I just outlined and just drew. So I'm just going to write 1 here. So I think it factors to 3x minus 2 times x plus 1, and that's equal to 0. So let's make sure I get this right. So it's here, let me get a pointer. 3x squared, 3x times x is 3x squared, that checks. And then 3x times, here, I'm going to write it over here and then erase it. 3x squared, and then 3x times 1 is 3x. And then I'm going to multiply the next part through, and let's see. So negative 2 times x is negative 2x, and negative 2 times 1 is negative 2. So if I combine those, I get 3x squared plus x minus 2, and that's what it's supposed to be. So we're good. That's all we need. Let me clean that up for a minute. So then we have to apply that zero product property, where we say 3x minus 2 has to equal 0, because if this equals 0, the whole thing is 0. And for that one, I'm going to add 2 divided by 3. So x equals 2 over 3. And then the other one, we got to ask ourselves, where does x plus 1 equal to 0? Well, I'll just subtract 1. So x equals negative 1. So those are the two solutions. This is where this equation crosses the x-axis. All right, and that's factoring. It really doesn't get any harder than that. Different combinations. This template works really well. You can grab a copy of this and print them if you want, or copy them down. There's other ways to do this too, but I think for this year, with trying to learn this on your own, this is a good way to do it. Mrs. Bruckner calls this the AC method. You'll see that again with her.